Now, someone check it out. I'm there now. Just setting it up. It should be back online in a second. Copy. Don't let it go off again.
What game are you playing?
007.
What does that have to do with physics?
Come on, I'll show you guys.
Man, where are we? What is this place? Why are we here?
I walked into the game to show you the physics of guns.
The physics of guns?
The physics of guns.
Alright.
Let's go. Careful though. We are in the game, so if we get shot, we are dead basically. So lock and load.
I have lives though.
Only one. Whoa, 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 whoa! Bond.
James.
Bond. Who are you?
Me? Why you need to know?
Who are you, my good sir?
Ben Nevis. How did you guys get here?
We got here through the N64. We came to learn about the physics of guns.
Well then, I'm about to teach you on your first lesson of guns.
Hey guys, my name is Dr. Kelvin Klein, and I went to the University of Nothing, studied nothing, and minored in Pepsi. So today I'm going to teach you about the basics of guns. So all guns revolve around one similar concept, and this concept is applying an explosive force behind a projectile to launch it straight down the barrel. Now, a good and early example of this is a cannon. Beautiful, isn't it? Now, basically, we have here an open end where the little projectile launches out and it's open, and a closed end where it's closed off. Now, the projectile sits in the barrel in here, and it's the cannonball or a projectile. Now, behind the cannonball, there is gunpowder. Yeah. And this is made from charcoal, sulfur, and potassium nitrate, which is very explosive and generates a lot of heat, which causes it to shoot out. Now, in order to shoot this cannonball or projectile, we need to light this gunpowder with a fuse. Now this fuse is made of a flammable material, and once you light it, a flame travels down into the gunpowder, which ignites the gunpowder. Now, once the gunpowder is ignited, it generates a lot of hot gas, which causes it to explode, which causes the projectile to launch out of the cannon. And that is basically how it works.
Okay, other scene.
Let's go.
Hello guys, my name is Anthony Velasquez. I majored in nothing and minored in crab anatomy. Today I'm going to be teaching you about the physics of guns, but more in detail, the firearm efficiency. To begin, as my partner mentioned before, firearm is basically like a mini cannon in your hand. But instead of these guns having a fuse to it, we have a hammer which basically replaces the fuse. Okay. For firearm efficiency, we basically have to think about the input that's being put into the machine and the output. As output, it basically works like a piston. With the pressure inside the gun, we basically get heat, and that heat causes the bullet to shoot out of the gun. Things that can help either improve or decline the speed of the bullet are basically caliber and the barrel length. They each go hand in hand because basically caliber, which ranges from .17 to .95, or you could just say 17 to 95 caliber, basically measures the diameter of the bullet. With barrels, there can be short, long, and medium barrels. The longer the barrel, basically, the more accuracy you have and the more heat retained inside the barrel, which makes you have more consistent shots without losing that much accuracy. People who get mid-range barrels, kind of like shotguns, basically, even though it's not for range, they lose accuracy, but it's also more portable than carrying a large sniper rifle around. Okay, let's go to my example about the USP gun. Go.
Hello class, my name is Fan of Nestev, and today I'll be teaching you in the physics of guns, particularly in the force, momentum, and the velocity. Okay, shall we begin? If the gun and the force are at rest, the force of the bullet is equal to that of the gun shooter. This is explained in Newton's third law, which states that for every reaction there is an equal and opposite reaction. The gun has a mass m, and the gunner has a mass m. When the gun is fired, the masses have a new velocities v and a big B respectively. But the law of conservation states that the magnitudes of their momentum must be equal. Okay, so we have here mv plus mv equals 0. That's equation number 1. Since the force equals the rate of change in momentum,